Okay, so for our next part, it is the ALU. And so in our case, it's going to look like this, where we have the multiplier and the adder um, in parallel with each other, basically. And here are the multiplier on the schematic on the inside, and here is the full adder as well. So the inputs for both of these are a 4-bit input A, let's call it, and a 4-bit input also B. And the output is a 5-bit for the adder, and as you can see here, and for the adder part of the ALU, and the output is 8 bits for the multiplier, as you can see here. All right, and so um, something to note is that both the adder and the multiplier make use of sequential logic using smaller blocks of adders and that add 1 bit together, and smaller blocks uh, that multiply 1 bit respectively for each one. So we have the adder here, or sorry, we use both the adder blocks for both the multiplier and the full adder, but they use different logic in order to achieve their goal. And in order for this block to work correctly, it needs muxes before the inputs, as you can see here. We need these muxes so we can select the inputs we're going to perform the arithmetics in. So this A is going to be inputted into this multiplier, and then the B is going to come from this mux. And we can also put that to our adder slash multiplier. Um, we also need to use a mux to select if we want the multiply value or the added value. So this will help us ultimately uh, give us the output from the ALU. In order to test this, I have some files here, but I would use the same fundamental frequencies for pulses, uh, but at different harmonics, such that almost all combination of numbers are added and multiplied together. Here, I basically just did that same thing. I used this adder file where the pulses are offset like here. And yeah, so that's what I did for both of them in order to test it.